Good morning, everybody. So today's assignment is talking about tangents. So let's just review again. Remember tangents. If the tangents intersect at the same point, they will be congruent. So RS will be congruent to RT. Also remember that tangents will create a right angle with the radius. So a lot of times when you have tangents, you will be able to use Pythagorean theorem. Again, remember Pythagorean theorem is a squared plus b squared equals c squared. If you have a right triangle, that will help you find a missing side. So here would be my right triangle, and I would be able to find any of those missing sides if they gave me two of them. Okay. Remember, tangent only touches a circle at one point. You can see the example right here. Shows you an example of a right triangle that you would be able to find. All right. So if I look at this question right here, so assume the segments that appear to be tangent are tangent. Okay. So in this picture right here, we see that, oh, it will not go away, that my radius is 19. So all of these sides are 19, which means that it is a square. So everything is 19. So x is equal to 19 in this picture. 2, this is just a right triangle because the tangent, which is right here, is going to be perpendicular to the radius. So there's a right angle here. So I have a right triangle. So 15 squared plus 20 squared equals my x value squared. 15 squared is 225. 20 squared is 400. 225 plus 400 is 625. If I take the square root of this value, we get x equals 25. Okay. In this picture right here, this one's just straightforward. Both of these segments are tangents. Since the tangents intersect at the same point, they're going to be congruent. So since one tangent is 12, the other tangent is also 12. Okay. If we were to look at this picture right here, so we need to figure out what we know. So we can see that my radii are 30. So this is going to be, oh, this one also is going to be 30 right here. Okay. My two segments are both 40. So from here to here, oops. From here to here is 40, and from here to here is 40. The 30 that is drawn is my radius. So if I would like to, I could actually draw another radius anywhere I'd like, maybe specifically right here. And I know that radius is going to be 30. Now notice that I have a right triangle. If I need to, I can draw it over here to the side. Okay. This is going to be a right angle. This is 30. Whoa, sorry. This is 30. This is 40. And this is the value we're trying to find. So 30 squared plus 40 squared equals x squared. 900 plus 1600 equals x squared. 2500 equals x squared. Take the square root, and x equals 50. So technically, this whole side equals 50, but I already know this part equals 30. So what is left for x? Our x is actually going to equal 20, and I should have probably used a different letter since x meant something else. So I could use y. Maybe that'll make it a little bit better. Okay, and the x value in the picture is 20. 5. So again, right triangles. This is a radius. This is a radius. All radii are the same, so these ones are both 21. Okay, I have a right triangle. My right triangle over here. We know this side is 21. This whole side is x. If I want to find the length of this whole side, it's 21 plus 8, which is 29. So 21 squared plus x squared equals 29 squared. 21 squared is 441 plus x squared equals 29 squared is 581, I believe. Let me check. Oh, I don't have my calculator up right here. I have it on my computer. Right here. Oh, sorry. 29 squared. Whoa, I was way off. Good thing I checked. It's 841. That makes a whole lot more sense. Subtract 441 from both sides, and x squared equals 400. Of course, take the square root, and x equals 20. Okay. Gonna be the same idea over here. These are both 5. This is also an x. This also is a radius, even though it's a part of that segment. So this one's also 5. Notice now that I have a right triangle here, and I can use Pythagorean theorem. Okay. Page 2 talks about circumscribed polygons, which means the polygon is on the outside. We are going to find a lot of perimeters. Remember, tangents are going to be the same length. So you see right here, both of those intersect at the same point, and they're both tangents. So they'll both be 6. Same idea down here. They're both going to be 8. And these ones right here are both going to be 12 because they're both tangents that intersect, intersect outside of the circle, same place. All right, finding the lengths. So we want to know the value of x. If this is a radius of 8, if I draw another radius on here, it is also 8. 8 plus 8 gives me 16. Okay. 2, regular hexagon. Remember, we talked about regular yesterday. It means that all of the sides are the same. Okay. So that means if this is 4, this is also going to be 4 because they're both equal. In order for them to be regular, they all have to be the same thing. So they're all going to have to be 4. Otherwise, it would not be a regular hexagon. It would be just a hexagon. So my x value right here is 4. Okay, 3. So x goes from here to here. If you want the value from here to here, the whole distance is 12. Half of 12 is 6. All right. Question 4. Tangent, tangent. So those are both 2. Down here, a tangent and a tangent. They're both going to be 4. And here, tangent and a tangent. Those are both going to be 6. So if I want to find the whole value of x, I have 6 and 4, which gives me 10. Okay. All right, same idea still. Pretty much all the same idea with the tangents. 3 and 3. 1 and 1. 5 or 6. Sorry, I can't read today. 6 and 6. And last but not least, 2 and 2. All right, again, the whole distance is 2 plus 6, which is 8. All right, last one says equilateral triangle. Equilateral means all 3 sides are the same. So all 3 side measurements have to be the same in this picture. Okay. So for them all to be the same, all of these segments inside are going to be the same. So if this one is 4, guess what this one's going to be? Okay. All right. After you view this video, complete the next 2 pages, skills practice and practice, and let me know if you have any questions.